Hello students, today topic is supply of goods and production function. The supply of goods in the Solow model is based on the production function, which states that output depends on the capital stock and the labor forces. We can write as production function y is equal to function of capital stock and labor goods. The Solow growth model assumes the production function has constant return to scale. Recall that a production function has constant return to scale if this condition is satisfied. Any positive number z is goods capital stock and labor force are multiplied by z and z capital z labor and z output. Production function which constant return to scale allow us to analyze all quantities in the economy relative to size of the labor force. To see that this is true, set z is equal to 1 by labor force in the preceding equation to obtain. So if we set z equal to, then this equation will become y by l equal to function of k by l comma l by l, which is equal to 1. This equation shows that the amount of output per worker denoted by y by l is a function of amount of capital per worker k by l denoted by k by l. The number 1 is a constant and thus can be ignored. We designate quantities per worker with lower case letters, so small y is equal to output per worker is output per worker and capital per worker is capital per worker. We can then write the production function as small y is equal to function of per capital. So let's see y is supply of goods in the Solow model is based on production function, and the production function can be written as y, which is output, is a function of capital stock and labor goods. The Solow growth model is assumed, so we can write okay. Now to convert this production function in per worker terms, we will set the z equal to 1 by l, putting z equal to 1 upon labor force. This equation will become y by l equal to function of k by l comma l by l. Fine. In the next step, we can write as y by l equals to function of k by l comma l by l equal to 1. Now we will use lowercase letter, we denote per worker. So we will write small y output per worker equals to function of capital per worker small k denoted by small k comma 1. 1 is a constant, thus can be ignored. We next step we can write output function of capital. Simple. Here we have two axes. On the horizontal axis we taken capital per worker small k, and on the vertical axis output per worker denoted by small y. And this is our production function denoted by fk, which is equal to y, that is output per worker. The slope of this production function shows how much extra output a worker produces when given an extra unit of capital. This amount is the marginal product of capital denoted by MPK. Mathematical we can write in this form. Marginal production MPK is equal to how much extra output worker produces when given extra unit of given produces. We can define f k plus 1 is equal to output per worker for k plus 1 unit of capital, where fk output per worker for k unit of capital. So if a worker given extra unit of capital, then the increase in output per worker will be denoted by MPK, marginal product capital. You can notice in this figure, as the capital per worker increases in the production function, which exhibit the dimensioning marginal product. Let's see. Suppose capital per worker is denoted by K1, and average worker to work, so and extra unit of capital will be very useful and produces a lot of additional output. This is our marginal product capital, the increase in output per worker due to increase in 1 unit of capital per worker. Okay. Now if capital per worker is high denoted by K3, and average worker a lot of capital, in this case an extra unit of capital increases production only slightly. In this case you can see that marginal product of capital increase in output per worker due to increase in money return of small, as compared to this case. As the compared to this capital per worker, as the capital increases K1, K1 to K3, marginal product of capital dimension decreases. Okay. Thank you, and subscribe the channel.